Hey guys, so today we're going to be talking about logarithmic functions. This is the first part of 3.2. All right, so let's get right into it, right? Let's talk about exponents and powers first. So here we have the powers of 2, right? And when the exponent is 1, I have 2 to the 1, that's 2. When I raise the exponent to 2, now I have 2 to the power of 2, that's 4. And then 2 to the power of 3 is 8. So look at what happened here. I raised my exponents 1 to 2 to 3, but in going from 2 to 3, the value jumped from 4 all the way to 8, right? So I skipped through all of those numbers. Well, what if I wanted an exponent of 2 that would give me a value of 6, right? So now here is our question. What exponent of 2 will give a result of 6? Basically, 2 to the power of what would give me 6, right? That is the question. Well, to answer that question, what we need is a logarithm, right? A logarithm always answers the question of what exponent of a given base will result in a specific value. And to really be successful when you're doing logarithms or work with logarithms is in your mind to have this idea, this notion that a logarithm and an exponent are exactly the same thing. A logarithm is an exponent, okay? All right, so let's explore some logarithms. Look at what we have here. A very common statement, 3 to the power of 2 is 9, right? And we know that this 3 is called the base and the 2 is called the exponent. That equals to 9. Okay. I can rewrite that same statement in a different way. And I can rewrite it using logarithms. And I can say logarithm of base 3. You see how the base is the base here? Of 9 is equal to 2, right? So look at where the exponent is now. Okay, so what is this statement telling me here? What is this statement is telling me? When I see this on a billboard, if I'm walking down the street and I see a billboard and this is all that says on there, in my mind, I'm like, oh, somebody's trying to tell me that 3 to the power of 2 is 9. So it's exactly the same statement, okay? All right, so let's rewrite exponents, powers in logarithmic form. All right, so first I have 2 to the power of 5. Well, what's that equal to? 2 times 2 times 2 times 2 times 2, 32. Okay, here's the base, here's the exponent. So now when I rewrite that as a logarithm, I say log base 2 of 32 is what? So the question is, 2 to the what is 32? Well, the exponent is 5, so that goes here. Okay? All right, let's do another one. 4 to the power of 2 is 16. So how am I going to write that? Well, that's going to be log base. What's the base here? 4. Of what? What's the value? 16 equal to the exponent 2. Remember, what is a logarithm? It's an exponent. So a logarithm should always equal to the exponent. All right, here we're going to go backwards. I have log base 3 of 27 is equal to 3. All right, let's identify. This is a base. This is an exponent. So how am I going to write that? The base to the power of the exponent is 27. Okay? Fabulous. And this is how we can always go back and forth between logarithmic and exponential form. So now let's explore a little bit more. Let's explore the properties of 1 and 0 as exponents, right? You know that, an exponent of 1 and an exponent of 0 are always special, right? Let's start with 1. Remember, any number raised to the power of 1 is the same number. And any number raised to the power of 0 is 1. Okay, so let's talk about an exponent of 0 first. Okay, what's 2 to the 0? 1. So now look, I have base, exponent. So here I can write that as log base 2 of 1 is 0. Okay? What this is asking is, what should be the exponent of 2 so I get a 1? And the answer is 0. Okay, 3 to the 0 is 1. So if I write it as a logarithm, log base 3 of 1. The question is, what should be the exponent of 3 so I get a 1? 0. Let's do this one. 4 to the 0 is 1. Log base 4 of 1 is what then? What should be the exponent of 4 so I get a 1? 0. So now let's just do, instead of a number, b to the power of 0. Well, anything to the power of 0 is 1. Table to the power of 0 is 1. So as a logarithmic form, this will be log base b of 1. What should be the exponent of b so I get a 1? 0. Okay, let's step back for a minute. Look at what you have here. Do you see a pattern? I have log of a number 1 equals 0. Log of a number 1 equals 0. Log of a number 1 equals 0. So what does that mean? That means in general, log of any base of 1 is equal to 0. That's a very, very important property. All right, so let's do exponent of 1. 2 to the 1, 3. 3 to the, I'm sorry, 2 to the 1, 2. 3 to the 1, 3. 4 to the 1, 4. Hey, let's write these in exponential form. Log base 2 of 2 is equal to the exponent 1. Okay, let's do the next one. Log base 3 of 3 is equal to what? 1. Log base 4 of 4 is equal to what? So let's pause and ask what we're talking about here. What I have here is a base of 4, and I'm asking what should be the exponent of 4 so I get another 4? Well, the exponent should be a 1. Okay? Now, b to the 1 is b. Okay, so let's see the pattern here. Look, whenever I have log base b of the same number, the exponent is always 1. So when I have log base b of b, the answer is always 1. These two properties are super, super important. Okay? All right. So let's go over here for a minute. I just explained to you this one and this one. And here there are two more which I just kind of want you to take as truth for the time being. One is log base b of b to the x. When you have that pattern, log b, b to the x, the answer is just x. So for example, if I have log base 3, 3 to the x, these kind of go away and my answer is just x. Okay? Another one that I need you to just kind of take as truth for the time being is if you have a number to the power of log b of x, that's also x. So for example, if you have 2 to the power of log base 2 of 7, these kind of go away and you just have 7. Okay? All right, guys, let's do a couple of these. Okay, before we do some big time logarithms, let's recall a little bit about roots that we've learned before. Okay, roots can be written as a base with a rational exponent. So if I have the square root of 2, there's a tiny little 2 there. So I can write this as 2 to the power of 1 over this number 2. Here I have a 3, so I can rewrite that as 2 to the power of 1 over that number 3. 25 to the power of 1 over 3. Okay? Also, what we need to learn, or we need to remember, is remember fractions can be written as a base with a negative exponent. We did this before when we were graphing exponential functions. So if I have 1 over 2, that's the same as 2 to the negative 1. Remember that? Okay, cool. So now we're going to evaluate these logarithms. So here's what we're going to do. What I have first is log base 2 of 16. Okay, remember, what is a logarithm? An exponent, right? Let's all say that together. What is a logarithm? An exponent. Okay? All right. So the answer to this is an exponent. So here we go. The question is, if you have log base 2 to the 16, the question is, that's the base, right? So 2 to the what will give you 16? Sorry, getting ahead of myself. 2 to the what will give you 16? Well, 4. So the answer is 4. Let's do another one. I'm looking for the exponent of 5 that would give me a 25. In other words, 5 to the what is 25? 2. 2. Okay. Here I have a root. Before I can do the root, I have to rewrite the root 3 as a 3 to the 1/2. Remember? So now look at what I have. I have this pattern, log base to the power of something. These kind of go away and I have 1/2 left over. Okay. Okay, so this next one is asking me 8 to the power of what is 512, right? And for this, you can kind of do a little bit of, like trial and error with your calculator. 8 to the power of 3 is 512. So the exponent here is 3. Okay, this one. This is that pattern that I talked about before as well. B log B. 22 log 22 kind of goes away and you're left with 15.5. Here, I have a 3 and a fraction, right? Let's get rid of that fraction. So what I'm going to do is I'm going to rewrite the 1/3 as 3 to the -1. So now look, log 3 goes away. What do I have left? -1. Next, look at this. I have a whole number and a fraction. Okay, we need to rewrite it again. So I have log base 5. Okay, what is this business with the 125? How can I write 125 as a power of 5? Well, isn't 125 5 to the power of 3? Right? So now let's rewrite that as with a negative exponent. This is log base 5. And how much is that? 5 to the -3. So in the end, this is just minus 3. All right? Okay, so we will end here, and you can go ahead and do the logarithm handout due next time. Please make sure to have the handout completed before you come to class because I'm going to check. Thank you.